Okay?
Go.
Okay. Hello, my dear students. I want to complete the discussion of our lab report. This is the after lab debriefing and discussion of what we saw and what it means. But let's record our data first. And we had 3 beakers, one at 2 degrees Celsius. I don't need to put my units down because I have my units right here on my table. We had one at 21 degrees, that was room temperature. You don't need to write that. And one at 78, 79 degrees, hot water. Not boiling, because as soon as it starts boiling, it starts cooling down. And I borrowed this. I would have just said bright, brightest, and dimmest, but it asks us to score them on a scale of 1 to 3, 1 being the brightest and 3 being the dimmest. So the brightest one was clearly the hottest one, and the dimmest one was clearly the coldest one, and room temperature was in between. So there's your data, okay? I'm going to erase it now because we're going to move on to our questions. And when I move down to our questions, fortunately, the data list. So, which beaker contained the water temperatures? What beaker and what water temperature contained the brightest glow stick? I'll do it this way. The beaker with the hot water at, what was it, 78 degrees Celsius, had the glow stick that was the brightest. Remember, for full credit, you can't just say the hot water beaker. Add some information like the temperature, and remember everybody, Wicks. Write incomplete sentences for full credit. Now it says, how does the water temperature affect the chemical reaction? So what's happening is, in the hot water, the chemical reaction goes faster. It's using up reactants and producing more product, and some of those products are, or that reaction releases energy that elevates those electrons. And if you release more, you excite more electrons and you get brighter light, light of greater amplitude. So, the effect is that the rate of reaction increases with increasing temperature. And that rate of reaction is related to the brightness. You're also using up your reactants at a faster rate. So the ones in hot water will glow brighter, more brightly, but they will also be used up the fastest. My kids always have this disappointment. They go to bed with their glow sticks and they wake up in the morning and they're not glowing anymore. Theoretically, you may have heard putting them in the freezer somewhere to slow the reaction down so they last longer. That's true. Of course, you can't enjoy them in the freezer. And the last one is, what evidence do you have that a chemical reaction took place? And I'm going to write down here, I don't know why this thing is in my way here, but a chemical reaction takes place if And there's certain ways to tell without having molecular vision to see if bonds are broken and made. That's what happens in a chemical reaction. Bonds are broken, bonds are made. How do you tell? Well, scientists have a few ways to tell. One way is if a gas is produced, we look for little bubbles. That didn't happen. If a precipitate is formed, if there is a change in color, and, sorry, I'm trying to write around this problem, and in our case, if heat or light is given off or absorbed. I could explain that further. For example, you're absorbing photons when you do fission, which is a chemical reaction. So, and bonds get made and broken. So, anyway, these are our conditions. That's your discussion of the lab report. See you in the next one.